Uh, I'm Karl Jones. So today we're going to talk about the particle system, some of the new features, and a little bit about some performance tips and that. Okay, so first thing to talk about is the removal of a feature. If you're using legacy particles in 2018.2, it won't work. It's completely gone. So we have an upgrader tool, which has been on the forum for a while. So if you haven't tried that, you can try that link there or search for it. We don't have a script updater at the moment. Our current system doesn't support it, but we are working on trying to help people with that. And if you go on the forum, you can ask for some help in that. Is anybody actually using the legacy particle system? I wouldn't be able to see you anyway because the lights are in my eyes, but I'll assume no one is. So on with some features. First thing we've got is what we call ring buffer mode. So to explain a little bit about what a buffer is to sort of the non-programmers, you have the max particles, which is your list of particles or your buffer. And as you spawn a particle, that list fills up. And once it's full, as you might have seen, it just won't spawn any more particles. It can no longer spawn anymore. So in ring buffer mode, instead of blocking new particles from being spawned, we will kill the old particles, the oldest particles, and allow you to continuously spawn new particles. So I'll show you a little bit of what that looks like. So here's our default, and this little bar represents our buffer, or our max particles. So you can see as it fills, we can no longer spawn any new particles. Once those particles have died, then we can spawn them again. So with the new ring buffer mode, we have two ways of doing it. We have what's called pause until replaced and loop until replaced. So pause until replaced will play the normal animation of the particle, but instead of it dying at the end and being removed, it just stays alive at its last state. It pauses it. Loop until replaced will let you set a loop point, so you'll just continuously play that animation between those two loop points, and then when the particle is going to be removed, we play the remainder. So what that means with the loop mode is you will go over your particle limit whilst those particles are being animated. So that's something to be aware of if you're going to have a lot of particles. That max limit is no longer a hard limit. It's more of a soft limit that we'll aim for over time. So to give you an idea, during ring buffer mode, we no longer remove particles when their life expires. We just keep them alive. And that's to do with how it works internally, and that if we did allow that to happen, the order of their lives would kind of go out of order and it wouldn't be very good for performance. So we have to keep them alive. But in this example, I just fade them out. And to give you an example, this is the loop until replaced mode. So you can now see it just continuously will spawn new footprints, but it's actually gone over that limit. And then over time, it will remove them. And at a certain point, it will just reach its max limit. So this is very good for if you want to create like decal effects, such as this. You can now do like a nice cheap performant decal system, and you don't have to worry about that limit anymore. That limit can be used to help maintain performance. So you can see here, if I zoom in, it's doing the loop mode. So it's just looping a color, and then when it hits, it needs to be removed, it just shrinks it down. So I'll show you what that looks like. So here's our bullets particle system. And this is the new property, the ring buffer mode. So here we're using loop until replaced. And you can set what's called the fade time. So that is the time that it's going to play the animation. So here we're just playing our animation between 0 and 0.7. So it'll just keep playing that. And when we remove the particle, it'll play the 0.7 to 1 remainder of the animation, which for us is where we just fade out the size. You can see here. So that's the first feature. So the next feature, whilst we were fading out the legacy particle system, we wanted to make sure that we had feature parity so that we could do the exact same effect in the legacy system as you can in the new system, or sorry, the exact same effect in the new system as you could in the old system. And one feature we were missing at the end was what's called systematic mode. So in systematic mode, you can provide some mesh data, and it will spawn the particles in the order of the vertexes in the mesh data. So you can spawn them like sequentially. So to give you an example, a very simple one, Here we just spawn a single particle in order of the vertexes in that shape. But with this mode, you can now also interpolate. So we've extended it where we can now generate particles between the points on a path. So you can do things like this. So you can generate you can create an outline of a shape, such as some text, and then you can get the particles to spawn over time on them. So you can almost create an effect of following a path. So for example, you can create some nice effects like that. And that's just mesh data of the text, and then it will just follow that, spawn new particles. So it looks like it's moving, but it's not actually moving. It's using the ring buffer mode with the shape mode, so it will just spawn the particles along it. And then when it hits the limit, it just removes the old ones. To give you another example. So this mode is using sub-emitters with the new mode. So it creates like a single particle, which will just keep getting spawned along the points. And then it uses the child emitters to create the spark effect. You didn't expect that. So this is our sort of main feature that we've got coming out. We currently, if you've used the external forces module, you'll have seen that it only really supports wind modules or wind zones, so that it's quite limited in what you can do. So we've now added a new component called the particle system force field. So this is a completely separate component that you can add to a game object, and it will let you influence the particle system. So you can specify the shape of the field you want. So you've got sphere, cylinder, hemisphere, box, and they will have different influences. You can control what we call, in this we call it the inner radius and the outer radius. I think we're going to rename that to inner range and outer range. So what that means is you can create like a hollowed out shape, and you can say it will only affect the particles between this sort of shell. So for here, in this example, if I zoom out, I've forgotten what I'm doing. That's not what I want. We'll go and have a look at one of these force fields. Okay, so I'm just going to find the force field. So this is what the component looks like here. So we've set the shape to sphere. We've got the inner radius and the outer radius, which can be controlled by these gizmos. And if I disable this first, I'll show you what the effect looks like without the force field. So you can see the particles are just expanding outwards. So now when we enable it, when particles enter this dark area, it'll then have the effect applied to it. And then you can configure things like the strength, so we could make it, oh, sorry, it's not on. We can make it fire them outwards instead of pulling them in. Maybe I can get that to work properly. Anyway. So with this, you can also configure where the actual origin of the effect is being applied. So by default, it's going to be the center of the shape, but you can also make it affect the shell instead, so that particles are treated like almost like a force field, or like they'll bounce off the shell. And you can also do intermediate in between, so that's what we call the gravity value. So when you start to combine these features, you can create such as a cylinder, and you can create like a pipe effect that'll keep the particles in the pipe, or create like a vortex. So for example, here we've got a cylinder shape coming off the fan, and that creates a vortex effect, and then the particles are being sucked into the gravity. So let's have a look at how that's built up. So I'm just going to find that. So you can see our fan, if I navigate all the way down it, there's our external forces. So you can just turn these on and off like you would any other component. You can also animate the properties and modify them with scripts. And you can also configure which particle systems they affect. So you can put them onto layers and have it done by per layer, or you can also just provide a list of force fields to a particle system if you want to be very specific about which ones to use. So next feature, we've added some improvements to the texture sheet module. So you can now do fixed frame rate animations instead of it being based on the lifetime of the particle system. So you can just give it a simple sprite sheet and it will just animate regardless of how long the particle is going to be alive. So you'll get a consistent animation speed. And we've also added a feature where you can select frames based on the speed of the system. So if you want to have different effects based on how fast or slow the particles are going. A few other little features we've added. We've given you the ability to control the probability of a burst occurring. So it's no longer always going to occur. You can actually set whether that burst will occur. We've also exposed the min-max curve and min-max gradient, so they can now be used in a script independent of the particle system, and they will serialize, and they also have their own editor, so I can show you a little bit what that looks like. So you can add just a min-max curve and a min-max gradient. They're currently still part of the particle system namespace. In the future, we will probably make them more of a generic component, but for now, you just need to include them like that. So if you now add that as a property to your script, and if we go back to our script, min-max example, you can now just use them in your own scripts, so you can be a bit more configurable in the type of scripts you're creating. And they have all the same properties that you would have in the particle system versions. We've also added what we call bake mesh support. So this is in 2018.2. You can now query a line renderer, a trail renderer, or the particle system, and you can get the actual mesh data. So if you want to do something with that mesh data, or you want to do some performance improvements. So for example, with the line renderer, we added another feature where you can also, in the editor, modify the lines. So I'll show you a little bit of how you might do some performance improvements. So let's have a look at the new LineRenderer editor. Okay, so here we've got like a little city, and this is our new LineRenderer editor. So you can go into create mode, and you can now just draw in the world your line, and you have two ways of doing that. You can just do with physics or the mouse position. So I'm going to use physics. So now if I just click, I can just drag, and this will just create a line for me. So I just drag it anywhere. You now see it's created our line. And then we can go to edit mode, and we can actually go around and edit those points. So you can zoom in. You can delete individual points, if I can remember the key. No. You can drag them about. You can duplicate them, subdivide them. So for example, say I wanted to clean up this line now. I don't want to have to go through and delete all those individual points. What we can also do is we've got this simplify mode. So I enable the preview, and we can modify this tolerance. So the higher the tolerance, the less points you're going to end up with. And you can see the preview goes quite harsh. So let's say about that. So you see we've now got 148 points at the moment. So if I press simplify, so that's 19 points now. And it's still got quite a similar shape to it. Another thing quickly worth mentioning is the actual display of the points. If you've used the line renderer before, once you start to get to a line with like 1,000 points, the editor just seizes up because it just can't draw all those points at once. This one's a lot more performant. It can handle a lot of them because it only draws the points you're looking at. So the editor won't slow down once you start to draw more and more points, which is always helpful. So once you've got your line renderer, you might want to have multiple versions. You might want to generate some LODs. So you can use that simplify mode, and this can all be accessed in script. So you might want to generate a few different versions that are simplified, and then to improve the performance even more, you could use the bake mesh mode, because internally, the line generates its geometry every frame, and that's because by default, a line is designed to face the camera. So if your camera's moving, you have to keep regenerating that geometry to face the camera. But we've added that mode now for the lines where you can have them just face in a particular direction, but they still do generate that geometry every frame just because of the way it works internally. So you can now improve your performance by just using the bake mesh mode so that it doesn't have to do that. So I'll give you an example of what that script might look like. So here, we're just going to get the line renderer. We're going to create a new mesh component. You pass it into the line renderer with the bake mesh command. We have an optional command, which is use transform. So do you want the returned mesh to be in world space or local space? And then we do a little optimizing we call upload mesh data, which basically just removes the duplicate data so that in case you wanted to edit it in script. And then we just create a line renderer with it. And so what that looks like is this. I just enable that. So now it looks like the line renderer is still there. I'll turn off, sorry. But it's actually a mesh version now. So here's our mesh. So that's a nice little performance thing you can do to help with your artists. You can let them edit the lines in the world. And then at runtime or when you do a build, you can optimize those lines, use the simplify mode, generate some LODs, bake the mesh, and so you can get a bit more performance. So let's just go back to the summary of what we just done there. So you can now draw those lines in the world and edit them in the world, so you can clean them up a bit nicer. You can duplicate, remove, and subdivide those points, and you can simplify the line. And the simplify API is not dependent on the line renderer. You can just pass it a load of vectors, and it will just simplify them for you. And it has a 2D and a 3D mode. So if you've got a lot of CAD data or line geometry and you want to simplify it, it's really good for that. And you can use it with the ECS system. It doesn't have to be run from the main thread. And we've added the bake mesh support, so you can now also apply physics to your lines if you want to get some nice colliders for those line renderers. And what else can you do with bake mesh support? So particles, people often ask for UI particles, so you can just do that now. And what does that script look like? Because I know there's quite a few scripts on the forum that show you how to do UI particles by generating the geometry and putting it into the UI system. So now you've got the bake support, you can just do it with this. So that's our script there. All you need to do is just unpopulate mesh and just pass that mesh into the particle system. And we're hoping to improve that a little bit and make it a little bit nicer to create some nicer UI particle effects. But at the moment, you can just do this now. Use the bake mesh support and just pass that into particles, into the UI even, sorry. And that means it can now work with things like masking. So let's have a look. So I just enable the mask. And so that all will just work out the box now, hopefully. Once you, if you want to use trails, trails are a separate mesh. So you need to, there's another API called bake trail, mesh trails. So you'd need 2 meshes. And for sub-meshes, there are also meshes. So we'd like to make that a little bit simpler for you so you don't have to start configuring it depending on how many particle systems and subsystems and trails and that. So this is something we talked about a little bit in the past. We've improved it a little bit now, so I thought I'd show it. So we've exposed a property in the system called automatic culling enabled. So in the past, we've talked about what we call procedural mode and non-procedural mode in the particle system. So essentially, procedural mode means the particle system is able to predict at a point in time its state without having to simulate all the way to that point. So it means that it's a deterministic particle system. You know, like at a certain point in time, what color I'm going to be, what size I'm going to be, where all the particles are. But when you enable certain modules and properties, it breaks deterministic mode or the procedural mode. So for example, if you're using collisions, we can no longer predict the state of the system because we don't know what's happening in the rest of the world where colliders are going to be. And what that means is we have to continuously update the particle system even when it's not on screen. So we can't cull it anymore. And so you can get significant performance reduction when you have a lot of particle systems in the world and you might think they're all being culled, but they're actually all updating themselves. But what you can do is you can add your own culling. So we've added this property now so you can find out if it's even doing the culling. So if it's, you can check this and find out if it's enabled. And then if it is enabled, not culling it, you can then do your own custom culling. So here's a custom culling script we've created. And the one we provided in the past had a small bug in it. So by default, the culling group will always start in a culled state. where the particle system is always going to be in a visible state. And so you wouldn't actually get any performance benefit until the first time they actually change state, because the event is called onState changed. So what we now do is we just make sure we synchronize before we actually create anything to make sure they're both the same state. So if a particle system happens to start off screen, it's set to be culled instead of staying alive. So I'll show you what sort of performance improvements you can get with that. So here we've got a pretty complex system, and it's using the non-procedural mode, so it's very slow. You see it's in like 1-2 frames per second. So now if we enable our culling mode, you can see it's a pretty big performance improvement, and there is no visual difference. It looks exactly the same. So if you have a lot of particle systems in the world, it's definitely worth checking that, because you can get quite an improvement and you won't have to change any of the visuals. And you can see down here, we had 460 systems there, and now we're only updating the ones that are on the screen at the time. Okay, so just to summarize, we've now exposed that property. So if you want to check in script whether you need to do your custom culling, make sure you synchronize with the culling group the first time, just to make sure that they're both in the same state. Another thing worth being aware of is if you are calling from a script to a particle system and making changes at runtime, even if you're making changes that would normally be okay to be procedural, that will automatically break procedural mode because it's no longer predictable because you're making external changes. So if you do that, you can re-enable the mode by stopping the system, clearing it, and then pressing play again, or calling play in a script. So it's worth being aware that if you are making changes with scripts, they will automatically break procedural mode. And when you do cull the system, make sure to pause it so it doesn't have to update itself, and disable all the renderers as well to help a little bit more. So finally, an experimental feature we've been working on recently is adding ECS support, or the C# job system support, to particles. So if you've worked with writing your own scripts in particles in the past, you'll be aware that you have to call get particles, where we have to copy all of that data over to you. You then have to do some work on it, and generally that tends to get done on the main thread. And then you call set particles, where we copy all that data back across. So with the ECS system, we can now give you native access to the particle data, so we don't have to copy data back and forth. And it can also run in the job system so that you can run on multiple threads. So essentially, you can create custom particle modules and have your own different effects, and you'll still be able to get a decent amount of performance. So to give you an example, we start off here, we're using get particles and set particles, and we've got a simple script that just makes all our particles get drawn towards the mouse pointer. So I'll give it a minute, a few seconds just to slow down a little bit. I want to really kill it. So now if I enable our job system support, it generally kind of doubles it a little bit. It varies. So it's certainly worth using the ECS system with particles if you are doing your own scripts to modify things to help get that extra performance. And that brings us to the end. I think that was a bit quick. Thank you. And if you've got any questions, you can come up to either microphone.
Hi.
Hey.
Thank you. Great presentation.
Oh, thank you.
Those like this sphere and cube with the radius.
Are they external forces?
Yeah, the external forces. Will you support mesh as well?
Not at the moment, no. It's because we have to be able to generate like a volume, and to do meshes, one thing you can do is you can provide a texture, such as one you generate in like Houdini, I forget what the term is, like a volume texture. And so you could kind of do it with that, but we can't really do it, just support a mesh, because we don't have any way to know the volume of the shape in order to be able to calculate those forces.
I see.
So we have to use quite simple, primitive shapes.
Thank you.
Hello?
Oh, yeah.
Yeah, I was wondering if you're changing the noise module, because in the forces module I've seen some 3D textures already for, I guess, flow map support or 3D texture support.
Yeah, that's what I was just saying. So you can provide like a flow map texture, but it's not related to the noise module.
Okay.
It is a separate part.
And do you change the noise module at all? Because I'm a VFX artist and I'm using it almost on a daily basis, and I realized that sometimes there's some, it's jittering when you update some value, so it's really difficult to find like the sweet spot or something.
On what part, sorry?
So when you change, for example, the amplitude of the frequency and the 3D, 2D, or 1D texture,
Yeah.
I realized that sometimes it's recalculating, I think, the noise map. Or whatever it's doing, I don't know. But it's really difficult to just scrap a value and find the sweet spot because it's updating and then it's just jittering.
Too quick, yeah. Maybe file a bug report and we can look into it.
Okay.
We know there are some performance issues.
Right.
It's mainly to do with the editor because we have to generate a texture continuously, and that can be quite slow to pass
Right.
that texture rate data across.
Thanks.
Hi. Hi. I have a little question regarding the splines, especially the part where the particles were moving slightly slower on the curves.
Oh, yeah.
Are you planning to normalize that data? Because I
that
know
was,
my artist is going to ask about it.
No, that was because in that demo I had the mode where it spawns them on the vertices. And I did mention that we have the mode where it interpolates them smoothly. I just didn't have it on that one. So, yeah, you just need to switch the mode so that it does it where it basically positions them evenly along all the way instead of spawning on the vertices, and it does it smoothly. So in the other demo I had where it went along the shape of the object in that, you might have seen...
Okay, with the logo.
Let me go back. Where is it? So I think this one's got curves, and it should be even when it's going around the curves. It should be the same speed, consistent speed. So yeah, you can already do that. It's just on my first demo, I was just doing the vertices, and then the second demo, I did the smooth one.
Okay, perfect. Thank you.
Okay.
Hi, I have one more question. Is it somehow possible, assuming I have a fluid field that is simulated in each frame, where I have voxels, and for each of these voxels I have some force, could I somehow couple this with this particle system?
What, to apply the forces?
Yeah.
It depends how the forces are coming out. Maybe you could do it as like one of those vector map textures, or you could use the ECS system and just apply it yourself in a script.
Okay.
You probably wouldn't be able to do it in a force field component unless it mapped across. Or so if you gave it one of those textures, vector textures, then it might work.
Okay. Thank you.